adaptive immune response takes days to weeks to become activated, but is also responsible for immunologic memory. Now, the key cells of the adaptive immune response are the lymphocytes, the B and T cells, which are generated during lymphopoiesis. Lymphopoiesis has three goals. First, to generate a diverse set of lymphocytes, each with a unique antigen receptor. Second, to get rid of lymphocytes that have receptors that are self-reactive, meaning that they'll bind to tissue. And third, to allow lymphocytes that aren't self-reactive to continue maturing into secondary lymphoid tissue. Normally, hematopoietic stem cells within the bone marrow mature into a common lymphoid progenitor cell, which then becomes either a B cell or a T cell. To become a B cell, it has to develop into an immature B cell in the bone marrow, and then complete its maturation into an antibody-secreting B cell, called a plasma cell, in the lymph nodes and spleen. To become a T cell, it has to migrate to the thymus and become a thymocyte, where it completes its development into a mature T cell. So B for bone marrow and T for thymus. In T cell development, the common lymphoid progenitor leaves the bone marrow and goes to the thymus, because that's where the developing T cells, or thymocytes, mature. The thymus is a fatty organ that sits in front of the heart, and as we age, much like our waistlines, the thymus gets fattier and fattier. This fat crowds out the space that used to be reserved for T cell development, and it's one reason why cell-mediated immunity declines over time, which is a process called involution of the thymus. So the thymus has an outer cortex and an inner medulla. Within the medulla, there are epithelial cells which support the developing T cells, as well as dendritic cells which present antigens to developing T cells on molecules called major histocompatibility complexes, or MHC molecules. That's important because T cells have T cell receptors that can only bind peptide antigens if they're displayed on an MHC molecule, which is sort of like a silver platter. So if the T cell receptor can't bind to the MHC molecule, then the T cell isn't going to be able to do its job. So of course, a key element of T cell development is formation of this T cell receptor, which is made of two chains, an alpha chain, which is like the light chain of a B cell receptor, and a beta chain, which is like the heavy chain of a B cell receptor. The alpha and beta chains are made up of gene segments called V for variable, D for diversity, and J for joining. The beta chain includes one V segment, one D segment, and one J segment, while the alpha chain only contains one V segment and one J segment. Every person inherits multiple copies of the V, D, and J segments, and they can be rearranged interchangeably